Hello and welcome to another OMG video. Today we're going to be talking about estimating the percentage mass of copper. Now it's hard to identify copper using conventional redox titration techniques. So instead we use an indirect route using iodide ions. So let's get started. Step 1, I'm going to produce a standard solution of copper 2 plus ions. This one I've got on the left is copper sulfate. You would have seen this at both GCSE chemistry and AS level chemistry, which is blue. We could also use copper nitrate. We're just looking for a salt. My second step then, step 2, is react with iodide ions, okay? So for this one, we've got potassium iodide, that's going to be our source. And you can notice we've gone from that lovely blue colour to now a brown precipitate. And our reaction equation for this one is 2Cu2 plus 4I minus is going to give me 2Cui plus I2. That I2 or iodine is the product responsible for the brown precipitate. Step 3 is we're going to titrate that resulting mixture with thiosulfate. Now, our titration with thiosulfate has the equation. Now, the reaction occurring in this titration is 2 moles of thiosulfate added to 1 mole of diatomic iodine provides us with the following products. And the key thing about these is that we've got a brown mixture on this side and we've got a colourless mixture on this side. Now, because it would be quite hard to tell the difference between brown and colourless, we use a new indicator, which we haven't seen before in chemistry, but we have seen before in GCSE biology. Is it going to be starch? Okay, so we're going to have at the beginning a very distinct blue-black, and then it's going to turn to a straw / colourless mixture. So starch, remember, GCSE biology, starch is blue-black in the presence of iodine. So when we've got no more iodine, we will not have that blue-black colour. Now here's an equation summary. Okay, so our first reaction which is occurring is the addition of iodide ions to copper ions to form iodine, and my second one is a reaction between thiosulfate and iodine. Now, a really important thing is now to work out the ratio between thiosulfate and copper, because that is how we're going to work out our number of moles of copper, so ultimately be able to work out my percentage mass. So the first thing I want us to notice is that the ratio between thiosulfate and iodine is 2 to 1. Okay? My next thing is I want to know what is my ratio between iodine from equation 1 and copper. Well, I can see that it is 1 to 2. This means then, because my thiosulfate to copper is 2 to 2, that means that my thiosulfate to copper is actually 1 to 1. And this is really important for us to get our heads around. So let's have a go at analysing some data for estimating the percentage of copper using a thiosulfate and iodine titration. So a transition metal complex contains copper 2 ions. A sample of 4.242 grams of the complex was dissolved in 250 centimetres cubed of deionized water, and a sample of 25 centimeters cubed was taken and excess potassium iodide added. This was titrated against sodium thiosulfate of concentration 0.05 moles per decimeter cubed, and 28.35 centimeters cubed was needed to complete the reaction. A. Find the number of moles of thiosulfate. To complete that, I'm going to take my concentration of thiosulfate and my volume. So my moles of thiosulfate are going to equal the concentration times the volume, which is going to equal 0.05 times 28.35 divided by 1,000. This is going to give me a number of moles of 1.4175 times 10 to the minus 3. I've done part A. Next thing they want me to do is find the moles of copper in the original solution. I want you to note that the original solution is 250, but we took a sample of 25. So I'm first going to find my number of moles of copper in 25. From our ratio, we said that the number of moles of thiosulfate and copper is equal, which means that I have also got 1.4175 times 10 to the minus 3 in 25 centimeters cubed. But I need to find out how many are in 250. To do that, I'm going to times it by 10, because 25 goes in 10 times to 250. So my number of moles in 250 centimeters cubed, so I'm accounting for the total volume here, is going to be times by 10, 1.14175 times 10 to the minus 2. My next job is to calculate the percentage mass of copper in the transition metal complex. I know my total mass there, but I am yet to know what my actual mass of copper is. So to do that, I'm going to do the mass of copper equals its number of moles times its MR. So I'm going to take the 1.4175 times 10 to the minus 2, and I'm going to times it by copper's MR of the periodic table, which is 63.5. That's going to give me a total mass of 0.900 grams. To work out the percentage mass, I'm going to take the mass of copper, I'm going to divide it by the total mass, and I'm going to times it by 100%, which is going to give me an answer somewhere in the range of 21%. Let's check if, yeah, 21.21%. Make sure you've got that example down. There's a 4-step process. Moles of thio, calculate the moles of copper, calculate the mass of copper, and therefore calculate the percentage mass of copper. Here's one for you to try yourself. Make sure you pause the video. I will write down the answers next to each step so you can know whether you're doing it correctly. Good luck. Here is the first answer. My number of moles of thio is 1.75 times 10 to the minus 3. This means that my number of moles of copper in 250 is going to be that times 10. This means that my mass of copper in 250 is 1.11 grams, which equates to a percentage mass of copper of 35.85%. Hope to see you on another OMG video soon.